one thing I remind you of, guys, that test retake, remember that chapter 4 test that you guys got back? That we said we were pretty pleased with as a group. Remember, if you're retaking that, when's that got to be done by? By the end of the week, so Friday. So the grades got updated again yesterday. So if you need to check where you are JMC wise, be double checking that, finding out where you're at. But I strongly encourage you, if you were not satisfied with that chapter test, to get in and take care of that. I think Kyle and John, you already took care of that end already, right?
Yeah.
Okay, so just remind you, don't forget that, because that was a big part of your trimester grade, okay? All right, guys, so we kind of talked about what we're going to be working with today here. In 5.2, it talks about adding and subtracting. In this case, what's the phrase right here?
Numbers.
Mixed numbers. Mixed numbers, you know, you can turn into improper fractions, and we're pretty good at doing that, okay? And so simply put, our goal is to add and subtract the mixed numbers today. And I'm just going to jump right to it. Whoa, I don't want that. Jump right into it. Goal, add and subtract mixed numbers. All right. Example 1 is adding with a common denominator. Just to make sure here, guys, if I had a fraction, n over d like this, which variable represents the denominator? Okay, the denominator is way on the bottom, okay? I always thought it would be awesome to have a team called like the Fighting Denominators. I think that'd be a good one. The Union Fighting Denominators. What do you think about that?
Yes.
The denominators dominated AP tonight. The dominating denominators. Even that even better, huh? Like that one, Mason? Alright. They don't like my fun today, so let's rock and roll. How about volunteer to read the first one?
Wait, what?
I'll read the first example here. It says, Javier bought 23 1/5 yards of, what's the word there?
Hummus.
Hummus to build a vegetable garden. Okay. It says he topped the garden with 25 2/5 yards of mulch. How much garden material did he put in the vegetable garden?
A lot.
A lot. Okay, guys, I think this problem is pretty darn easy. It says it wants to know how much total it put there. Okay. Now, would you guys agree that this is an addition problem?
Yes.
Take the amount of hummus, the amount of mulch, put it together. You guys think that's all you're doing right there? You think you got a solution for me already, Brandon?
Yep.
What's your solution?
48 3/5.
48 3/5. Okay, I agree with you. Now I'm going to show you a couple different ways to do this. Now I think that looking at this right here, that's pretty gosh darn easy to do. Now we get away with being able to add right away because if I would line this up like a decimal, but between the whole number and a fraction, if I can imagine the decimal being between the whole number and a fraction, line it up like this, I could add the 25 2/5 like this. Okay? Now you're going to hear me talk an awful lot about this idea of potentially borrowing a value, or also maybe having a value of more than one to put back in as a whole today. All right? But right here, again, how much material did he have? Well, we would take the amount of hummus here, amount of mulch right here, and do what with those two values? You add them up. Okay? So if I've got a fifth of something and 2/5 of something else, how many fifths do you have? A lot of fifths, right? How many total? 3/5. Yep, you've got a 1/5 and a 2/5 value to add to get a total of 3/5 right here. Okay. All right, now guys, take a look at that fraction part, 3/5. When I get done with this, can that be simplified at all? Can 3/5 be simplified? The answer is no. Okay. Then I'm going to add my whole values. What's 23 and 25 add up to again, Brandon?
48.
48. So the question becomes, how much garden material did he put in the vegetable garden? You would say 48 and 3/5. What was the unit we were using up here, gang?
3/5, huh? Yards.
Yards. Okay. Well, that's pretty gosh darn easy, isn't it? Pretty easy. Okay. Now, there's another idea here that says we can also subtract with a common denominator. In which case, you got to be careful on stuff like this, and we'll look at some examples here in a bit that are more difficult than this. But it says subtract something with a common denominator. I like to line my stuff up from top to bottom. So I'm going to call this 4 5/8. And I draw my line between them like so. And then we're going to subtract 2 1/8. Okay, first things first. This whole idea in this section is going to be talking about adding and subtracting mixed numbers or fractions with a common denominator.
Yes.
So, let's do the math here. Let's start in the fraction part first. How about 5/8 minus 1/8? Can I do that? 4/8. Okay. And then how about the 4 minus 2 part, Brandon?
2.
2 and 4/8.
And then
Okay.
you get 2 1/2.
Yeah, this is the part right here you say, okay, I've done my operation right here, and now look at your fraction part of the mixed number, the 4/8 part, and ask yourself the question. And you should always ask yourself when you get a solution with any fraction in it, can that fraction be reduced or simplified?
Yes.
4/8 would reduce to what fraction, gang?
1/2.
Okay, so this part right here could simply be a 1/2, so my solution right here would be what?
2 and 2 1/2.
Just be 2 and a half here, right? 4/8 can reduce to what value? Half, right? All agree here?
Yes.
Okay, really easy, right?
Yeah.
All right, well, let's take a look at the second page here and see what we start getting into on the second page of our notes. By the way, did everybody have everything down first page-wise? All right. Let's go ahead and think about what's going on here in this second set. Oh gosh, there it is. All right, up top here it says solving equations involving fractions with common denominators. So as I look at this right here, I've got some examples written down for you. All right. Solving equations involving fractions with common denominators. I think that's the page I want right here. All right. Guys ready for this? It's pretty easy. You ready for this?
No.
Yes, no, yes?
I'm ready.
Okay. You know what, I think I'm going to change this a bit. I think what I want to do, I don't really want to call this solving equation. I think I'm going to add this in somewhere else. Let's change it to this. Solving, not equation, let's call it problems here. All right, this is where things maybe get more difficult for us, all right? In number one, I'm going to kind of divide this up into two parts, but let's say that I've got something like this. Let's say I've got 10 over 27 plus, how about 19 over 27? Okay, first things first, do you have a common denominator?
Yes.
You do, don't you?
Yep.
Okay. So what's going to happen up top, gang? You're going to add the tops, 10 and 19. So what is 10 and 19 going to add up to?
29.
29 over 27. Now, guys, I agree that that would be the right solution. However, is that fraction proper or improper? It's going to be improper, isn't it?
Yep.
So, what am I going to do here?
You make it 1 and 2 over 27.
How are you getting that, Brandon?
If it's 2 over 27, you make 1 whole out of it, and then you have 2 left over.
Okay, so I really like what you're saying right here. Where's that one whole coming from?
The 27 over with the one pair number.
Okay. So are you kind of telling me that, you know what, 29 is really the same as 27 plus 2? Is that what you're telling me?
Yeah.
kind of like that. And a 27 over 27 is really what value? 1, right? Hey, don't lose sight of the fact that all fractions are really some kind of a, what would be the word? All fractions are really what kind of a problem? Think operations, addition, subtraction. All fractions are what kind of problems really? What did you do with all the fractions to turn them into decimals last section?
Division.
Division, good, John. They're all division problems, so don't lose sight of this right here. I'm going to back up here just quickly. One thing that you may have to do in this, guys, is say, all right, here, right here, 29 over 27, that's improper right because the numerator outnumbers the denominator, right?
Yep.
Okay, just turn this into a division problem. Check it out, guys. Go 29 and divide it by what now? Divide it by what?
7.
Well, guys, how many whole times will 27 go into 29? Once. Okay, so we'll do my division longhand. What's 1 times 27?
27.
And then when I subtract right here, how about a remainder, gang? What's 29 minus 27?
2.
2. So what fraction of 27 do you have remainder as, or remaining? Well, it's 2. So it's the same as 1 and 2 over 1 and 2 over 27, right? Everybody agree there?
Yeah.
Okay.
1, 2.
So what do you guys think about that?
It's cool.
Easy.
It's pretty cool, right? Pretty easy. Now we looked at some easy examples on the first page and everything was just magically right because our fractions were all proper. They, for the most part, were simplified and you just had a whole number. Now number 2, I might want to put a star by this right here and say, all right, what happens if you have something like this in number 2? What if you have 4 3/7, say, plus, let's go, how about 6 6/7? Okay, I'm going to do this a couple of different ways, so I'm going to kind of split this one here a little bit. A couple of different ways to do this. I don't like the way stuff is written from left to right. I like to stack my stuff up. So I'm going to move this plus 6 6/7 down here. Is that okay, guys?
Yeah.
Okay, give me a second here. Whop! Ooh, isn't that cool? I think that's so neat, but I just Okay, let's go to the method that we kind of talked about on the first page right here. All right? Let's look at the fraction part first. What's 3/7 and 6/7 going to add up to here on the
9.
right?
7.
9 over 7, right?
Yeah.
And how about my 4 and
10.
6? 10. Now as I look at this answer right here, guys, 10 and 9/7. 10 and 9/7. How about that 9/7 part? Cool or not cool?
No.
Not cool. So I would never run around getting a tattoo that said 9 over 7, right? That's pretty much a sign that says you're not cool, right?
That's right.
Right? What am I going to do here?
You do the same thing like we did on the last one.
All right,
Be
and
11 with 2 over 7.
where's that 11 coming from?
That's from the 9 over 7.
Okay, so the 9 over 7, which is improper, I'll put my work over here. 9 divided by 7, gang. How many whole times will 7 go into 9?
1.
1 time. Okay, so what's 1 times 7? Well, it's 7. How about my difference here when we do the
2.
So really 9/7 is really 1 and 2/7, right? So maybe what I want to say here is this. When I have 10 plus 9/7, I'm going to cross this 9/7 out. This is really 10 plus, remember, put your whole numbers on the left, fractions on the right. Isn't 10 plus 9/7 here really the same as 10 plus 1 and 2/7 now? Okay? Well, the only thing I have left fractionally on the right side is what value?
2 7.
2/7. Okay. And then how about the 10 and a 1? Well, it'd be 11. Okay, so if you prefer that method right there, line stuff up. Say, okay, I've got a whole number on the left. And in this case, we had an improper fraction here. Well, we simply did the division of stuff right there. And said, you know what? We can work this out to be 1 and 2/7. So add that whole 1 into 10 and keep 2/7 as my fraction part. Our final solution there is 11 and 2/7, right? Everybody agree? Okay. Now, an alternative method to this might be the following, okay? Guys, mixed numbers, you know how to turn into improper fractions already, right? Okay? I'm not sure you'll like doing this method, but what I could have also done here is this. I could have rewritten 4 3/7 plus 6 6/7 as the sum of two improper fractions. So what's that mean? Well, guys, help me turn 4 3/7 into a fraction. What's 7 times 4 going to get you? 28 plus the 3.
31.
So the first mixed number is really 31 over 7, isn't it?
Yeah.
All agree?
Yep.
The second part, 6 6/7. Let's see, the product of 7 and 6 here is 42, isn't it?
Yep. Plus 6.
Plus 6, which would be 48 over 7, right? All agree?
Yeah.
Do you still have a common denominator to this point?
Yes.
Yeah, so we're good here. Check it out, guys. What's 31 plus 48 going to be up top? What's your 31 plus 48 up top going to be?
79.
So when I combine these two improper fractions from the mixed numbers up top, I've got 79 over 7, right?
Yep.
Okay, couldn't I simply divide 79 by 7 now? Let's see what we get. All right. Now division concerns me when we get going on stuff like this, so if you have troubles, let me know. But let's check it out. 79 divided by the 7. Let's see, how many times will 7 go into that first 7?
1.
1 time. Well, what's 1 times 7, gang?
7.
7. So in that first column, 7 minus 7 is nothing, right? Bring your 9 down. Now ask yourself, how many times will 7 go into the
1.
1 time? What's 1 times 7 again?
7.
So when I subtract 9 and take away 7, what's your remainder?
2.
I got 11 and what value again? Well, don't you have 11 and 2/7 there again? That's a 7 right down here. Aren't they the same values, guys? I'm just going to ask the question, how many like method number 1? How many prefer method number 1?
I do.
I think I do too. Okay, how many like the second method? Turn stuff into mixed numbers, put it together, take the mixed numbers, turn them into impropers, add the impropers, and then work backwards to find out what that would be in mixed number form. Either way is fine, okay? Either way is fine. So let's try another one here, guys and gals. Make some room here quickly. Give me a second.
I don't have any room left on my paper.
Uh-oh. I bet if you got a different sheet of paper out and just said that this was example 3, that'd be all right, John. All right, let's try another one. You guys, let's try this one. Let's go. Ooh, I like this one. This one here almost forces your hand. We're going to make this a subtraction problem. 11 and 3/10 minus 7 and 7/10. Okay, first of all, what operation is this? Subtraction, all right? This one here is a subtraction problem. Now, I'm going to tell you this right now. I had 2 methods up here in number 2, okay? First method, just add the whole numbers, add the fractions, okay? Second method, turn everything to a mixed, take your mixed numbers, turn them to an improper, and add. Now, the method that will work consistently every single time is the second method right up here. And guys, anytime you have a subtraction problem like this, I would almost encourage you guys to do the second method. But I'm going to show you both ways here, okay? Again, I'm going to stack stuff up. I don't like stuff being written left to right. So I'm going to rewrite my problems and stack them up. Okay, let's check method number 1. Subtraction can be difficult. Okay, subtraction can be difficult. All right, kiddos, I could do the 11 minus 7 part. We know that would be what value? 11 minus 7 would be 4. Here's the problem I run into. Up top, in that first mixed number, what's my fraction part? 3/10. And from that, you're subtracting 7/10. The problem is this. If you've only got 3 to start with up top, can I take 7 away in the bottom?
Yeah.
You've only got 3 up here, can you take 7 away?
You gotta borrow some.
You've got to borrow. Okay, and if I'm going to borrow right here, I've got to borrow from which value?
The
whole.
11.
Okay, so this one right here, I've got to borrow from the 11. I'm going to borrow a whole 1. Now, what I'm going to tell you is this. Listen carefully. If you start borrowing under subtraction, the 11 is going to drop down to what value?
10.
10. Now, what I'm going to tell you is this. This is the rule. Anytime you borrow, you always add your numerator and your denominator in that top fraction together. So what's the 3 plus 10 going to get you? 13 over 10, right? That would be a 13. Okay, it's like adding 10 tenths. Isn't 10 over 10 the same as a whole? It's like 10 out of 10 pieces of pizza. Isn't that the whole pizza?
Yeah.
So if I'm going to add something that's, split up into 10 different parts, the whole thing would be all 10 of them, right?
Yep.
Okay, you already had 3 out of 10 to begin with. If I add 10 out of 10, or a whole 1, to the 3, what's the 10 and the 3 going to be, kiddos? Well, it would be what? 13. So now that I've borrowed right here, let's roll. How about the 13 minus 7 part in my fraction? In the fraction, 13 minus 7.
6,
6 over what?
10,
All right, and then the 10 minus 7 would be what?
3,
So 3 and 6/10, and again, I'm going to ask the question. Look at your fraction part in your solution. Do you like it, or do you want to do something with it?
you divide them by 2,
Okay, so what's this final solution going to look like?
3 over 5.
So 3 and... Excellent. Okay? So there are cases under subtraction which says, I might not be able to just jump right into subtraction. I may have to do some borrowing first before I can perform the operation. If you like that method, great. Alternatively, I could also say, you know what? Let's look at this in this situation here where I'm going to take... All right, I'll rewrite the problem again. What was that problem again? 11 and 3/10. Was that right, guys?
Yeah.
11 and 3/10 minus 7 and 7/10. So let's turn stuff to impropers. Turn stuff to impropers. Here we go. What's 10 times 11, guys? What's 10 times 11? Multiplying by 10, just throw a what on the end of 11? A 0, be 110, right? 110 plus the 3 up here would be? 110 plus the 3 would be?
113.
113 over 10 right here, right? What's my second fraction going to be, kiddos? 77 over 10. Excuse me. Holy cow.
Holy cows, he said.
All right, so up top, I can take 113 minus 77, which I believe is 36. So I've got 36 over 10. Once I've performed the operation, 36 over 10 is improper, so let's run it as a mixed number. So I'll put the work rate down here, guys. 36 divided by 10. How many times will 10 go into 36? Holy.
3.6.
Well, so just 3 whole times then, right? 3 and some change. When you say 3.6, it's like 3 and some change, right?
Yep.
So 3 whole times. So help me out. What's the product of 3 and 10 when I do my division? 30. Okay? So 36 minus 30 is what value? 6, right? So what fraction of 10 remains here, kiddos? What's up, Mickey? Okay, can you give me like 2 minutes? All right. What fraction remains then? 6 over what?
3 and 6.
You can hang out. Just hang out back there quick, okay? All right, so you're going to have 3 and 6 over 10. Now again, guys, the idea is simply the same. We had 3 and 6 over 10 up here, but we said, you know what? That 6 over 10 could get written as...
Yeah.
What fraction? What was 6 over 10 reduced to?
3 and 3/5.
3 and 3/5. Okay, same thing. All right. All right, so just real quickly, knowing that I might have to borrow under subtraction, how many people are going to still stick with method number 1?
I am.
I would probably too. I like method 1, okay? Just got to be wary of some tricks, okay? What method do we say is going to work every single time? Method number
1.
2 will work every time. turn mixed into improper. Kind of mix up mixed numbers and improper fractions, so then it's not even fun. All right, let's have you guys try some on your own. Ooh. Let's try these on your own. Let's go 3 and 2/11. Let's go. Ooh, I like this one.
5,
All right, give those a shot, gang. See what you come up with. All right.
6 over.
Bring that sheet up here and I'll write that down, Mickey.
Sorry. Ah! What? I'm sorry. Alright already. No, I'm good.
And then grab your notes. There's 5-3 notes over there and a 5-3 quick quiz, all right? All right, good luck. Yeah.
Is this just gonna be 18 or 19?
Yep. Yep. Give you guys about 1 more minute here, or 2 or so, or whatever we need.
Ooh. Whatever you feel, let me know. I'm sorry.
You want
What?
go to a basketball game like last night.
Yes.
All right, I'm gonna go ahead and get started on this so we can finish up the notes here real quickly. Guys, my first one, we're adding. How about 4/11 and 2/11? Can I add that up nicely right away?
8 and 6/11.
Okay, the 4 11ths and 2 11ths would be 6 11ths. How about the 3 and the 5? What's that add up to?
8.
2 questions about the fraction part, 6 11ths. First of all, is 6 11ths proper
Yeah.
or improper? Secondly, is that proper 6 11ths simplified, or can we simplify it further?
It's simplified.
It's already simplified, so we're done, 8 and 6 11ths. So just show of hands on that one. How many had that one correct? Okay, so we're in good shape there. Now the one that might be kind of difficult is this one right here. I'm going to write this as 9 1/3 minus 3 2/3 like so. Now this is one of those ones that's subtraction to say, okay, the 1/3 part minus the 2/3 part. If I start with 1/3, can you take 2/3 away from that? No. So in that case, what are you going to have to do? Borrow from the 9. Turn the 9 into what value, Mason? 8. How about my numerator for the 1/3? What's that going to become? 4/3, right? Okay. If I'm borrowing from 1, to get your new number up top, you take the 3 plus the 1, which makes that a 4. Okay, so here we go. Fractionally, what's the 4/3 minus the 2/3 part right here in the middle? 2/3. And how about my 8 minus 3?
5.
5 and 2/3. How many had 5 and 2/3 there?
I do.
Are we okay 5 and 2/3, gang? Max good? No? Yes? No?
Yeah.
Yeah? Are you with me on this?
Yes, I'm with you.
Now, does anybody want to see if I turn these into improper fractions and go that route?
No.
Are we okay with this?
Yes.
Okay, my last one. I have 16 27ths plus 17 27ths. I'm just going to go ahead and add the numerators. What's the 16 and 17 add up to? 33, right? Can I leave my answer as 33 over 27?
Yes.
That's improper, right? So how many times will 27 go into 33?
1.
Once. Okay, so let's just do this down here. If I go 33 divided by 27, one time you said, right?
Yep.
My remainder is 6. So I have 1 and 6 27ths. I have 1 and 6 27ths. Can you guys think of a number that will divide evenly into 6 and 27 so as to reduce that fractional part? 3 goes into both, right?
Yeah.
How many times will 3 go into 6 here?
2.
And here? 3 will go into 27.
9.
So 1 and 6 27ths would be equivalently in simplest form 1 and 2 9ths, right? Okay. And again, I want you to put stuff in simplest form. So make sure you're always checking, say, what does that fraction look like? Can I simplify it? Don't forget to do that. All right. Anybody need more time with this page?
No.
Everybody have that down? Questions to this point?
No, it's still
Okay, last page that I want to run through real quickly. The on your own is a typo up at the very top. So I'm going to get to example 3, and then I'm going to leave you with some on your own problems to give a shot to try for tomorrow. Okay, but it says adding and subtracting with variable denominators. Variables in the denominator. Idea being here that everything is still a common denominator. So here we go. Let's say that you've got 6 over 21a plus 8 over 21a. Now guys, everything is the same. Are the denominators equal again?
Yeah.
Okay, so that's good shape. So what am I going to do with the 6 and 8 up top?
Yeah.
So would you guys agree this is really 14 over
21A.
21a?
Yeah.
Okay, here's the tricky part. Here's the tricky part. Put the variables aside. Just forget about the variables. I have no idea what it is. Look at the 14 over 21 part.
Divided by 7.
7's a common factor for each, right? So if I divide both sides by 7,
2/3.
yeah, 7 will go into both of these, right? Put a 7 up here and circle it, so we're going to put that factor in there. How many times will 7 go into 14?
2, 3.
3 what, though?
3.
How you guys feel about that?
Good.
Concept's the same, they just start throwing a letter in there for you, don't
Easy.
they? Okay? Alright. So I guess what I would ask you guys to do is try the following. I want you guys to try the following problems here for me for tomorrow. Let's call this right here.
I can just take one from you.
You guys try these for me. This is what you're gonna solve for me for tomorrow, okay?
25.
So make sure you get these written down. We'll come back, we'll start class with these tomorrow.
You can whisper it. Oh, see you. Is it black there? Yes. And you're-
Okay, so have those 3 written down at least.
And we cannot use a decimal, right?
I don't want you to use decimals, no. Nowhere in this section are you using decimals, okay? And you know what, I'm gonna be a pretty nice guy, and I'm gonna say that's your only assignment for tomorrow right there, those
All right.
3. Now again, I want them in fraction form, but don't forget, that fraction needs to be in what form? Simplest form, okay? Don't forget that part of it, all right?
Thanks for only giving us 3 problems.
Yes, thank you.
You're welcome.
This is just together.
Let me know when you've got that down, I'm gonna stop recording here.